Good morning, students. In this session, we'll be discussing about PlayFair Cipher. Before going into PlayFair Cipher, let us discuss about cryptanalysis of Caesar Cipher and monoalphabetic cipher. In case of Caesar Cipher, the key space is very limited. It is only 26. Hence, you can easily break that Caesar Cipher using brute force attack. That is only in 26 attempts in best case scenario. In case of monoalphabetic cipher, the key spaces increase vastly. It is 26 factorial. It is very, very huge. But it is vulnerable to another kind of attack that is known as statistical frequency analysis of single letters. It means that the pattern of single letter found in plain text is also being reflected in a pattern found in the cipher test. So in order to overcome this, we'll be using PlayFair Cipher. In PlayFair Cipher, first we'll be constructing a key matrix. It is a 5 into 5 matrix. First, we'll be filling that matrix with a keyword. Once the keyword is filled, we'll be filling the remaining matrix with the remaining alphabets. Thing is, the keyword should be unique, and all the characters in that matrix should be unique. Here, the character I and J are treated as the same. For example, if you have the keyword rabbit, first we will be filling that matrix with rabbit, DRAVI, and the last character D is repetitive, so we are omitting it. And then remaining matrix is filled with the remaining alphabets which are not found in the key. Next, we'll be constructing the diagrams. Diagrams are sequence of 2 letters. It is used to overcome the single letter frequency analysis in monoalphabetic cipher. For example, if you have the plain text success, it is divided into multiple diagrams. First diagram is SU. Since it is unique, it is represented as it is. Then you have CC. Here, the characters are repetitive. So, we are replacing the second character with the filler character known as X. So, CC becomes CX. Then you have CE. It should not be a problem. Then you have SS. Both the characters are repetitive. Therefore, we are replacing the second S with filler character X. Then we have a single letter S. So in order to make it as a diagram, we'll be adding a filler character X. So it becomes SX. And then we will be substituting. There are 3 cases. In first cases, the 2 characters in the diagram happens to be in the same row. In that case, each letter is replaced by the character to its right. For example, CE is encrypted or substituted as EF. In second case, the 2 characters in the diagram happens to be in the same column. In that case, each character in the column is replaced by the character below it. For example, DU is encrypted or substituted as BD. In third case, the 2 characters in the diagram happens to be in different row and different column. In that case, each plaintext letter in that pair is replaced by the letter that lies in its own row and the column occupied by the other plaintext character. For example, SX is encrypted or substituted as QY. Now let us see that example success. Success is divided into multiple uh, diagrams, that is SU, CX, CE, XX, XS. Now SU is encrypted as OY. Here O happens to be in the same row as S, but it is in the same column as U. Therefore, S is replaced by O. Similarly, U is replaced by Y, which happens to be in the same row as U, but in the same column as S. Then you have CX. C is replaced by E, which happens to be in the same row as C, but in the same column as X. Then X is replaced by W, which happens to be in the same row as X, but in the same column as C. Then you have CE. Here C is replaced by its next character E, and E is replaced by its next character F. Then you have SX. Here S is replaced by Q, which is in the same row as S, and which is in the same column as X. Okay, right. Now let us discuss about cryptanalysis of PlayFair Cipher. Here, single letter frequency analysis is very difficult because it is the pattern is disappeared in the cipher test, but it is vulnerable to statistical frequency analysis of diagrams. That is, the pattern of diagrams found in plain test is also being reflected in cipher test. So that is the problem. With this, we will conclude this session. Thank you.